Hello, and welcome to today's webinar, Pulse Policy Secure Context-Based Admission Control. Before we begin, I would like to let everyone know that we will take questions toward the end of today's presentation, but you can submit your questions at any time using the Ask a Question tab above the presentation console. Now, I would like to turn the presentation over to Lisa Lorenzen, Principal Solutions Architect at Pulse Secure. Lisa?
Thanks, Craig. It's nice to be back. So today we're going to talk about context-based admission control with Pulse Policy Secure. Pulse Policy Secure is designed to help address some of the major challenges facing enterprise environments today. The rise of mobile devices means that we as employees and end users are most productive when we can work on our own personal devices and when we can work from smartphones and tablets, as well as from the traditional laptops and desktop systems that we've always used. But this brings additional challenges because it's incredibly easy to leave those smartphones and tablets in the pocket of an airplane seat or in the back seat of a taxi. So how can an organization enable that kind of mobile activity while still protecting the applications and data and the network itself? A third big challenge is compliance. There are all sorts of regulatory frameworks, from HIPAA to PCI to FISMA, that require not only that you protect your data, but sometimes, more importantly, that you be able to prove to an auditor that you're protecting your data. So all of these challenges are the impetus for the Pulse Policy Secure solution. And we've tried to create a solution that allows you to address those challenges and enable productivity while still providing comprehensive security for your organization. Policy Secure offers comprehensive visibility. Who's on your network? What platforms are they connecting from? Are those platforms compliant with your security requirements? What resources are people accessing? Visibility is foundational to the ability to create access control policies and enforce secure access within an organization. So once you know what's on your network, the next step is applying appropriate controls. And context-aware NAC policies allow you to consider not only the user's identity, but what role they play in the organization, where they're connecting from, possibly the time of day, what type of device, whether it's a corporate managed device, a personal device, a corporate asset. All of these factor into access control decisions that can be applied across remote and local users and across personal and corporate devices. What you end up with is a centralized locus for control and a consistent user experience regardless of how they're accessing resources. The third major pillar of Policy Secure is simplifying BYOD. Automated onboarding, the ability to enroll a device, and the ability to integrate with existing wireless infrastructure all combine to make it easy and secure to connect wireless users, whether they're on personal devices or corporate devices, for mobile access. Pulse Policy Secure offers two primary enforcement modes for applying controls. The first enforcement mode is admission control at layer 2, which is implemented via 802.1x and Radius. The other enforcement mode is network segmentation at layer 3, using firewalls as enforcers. Today we're going to drill down into the admission control enforcement using 802.1x and Radius, and in a future segment we will talk about the layer 3 based network segmentation. On our last webinar, we walked through the collection of tools in our toolbox. Policy Secure is a solution composed of multiple components working together. And like any toolbox, you wouldn't use every tool for every project. We would pick the appropriate tool to accomplish particular goals. In the case of admission control, everything starts with the policy server. This runs on our PSA gateways or virtual appliances, and it serves as Radius server and a host checker, checking the posture of the endpoints and pushing out policy to the enforcement points in the network. Obviously, the next component of the solution is the endpoints themselves. Windows, Mac OS, Linux, iOS, Android, legacy desktop devices and new mobile devices. All of these devices want to connect to the network, and in order to do so, they're probably going to be going through either a wired switch or a wireless network. Admission control generally applies inside the network. If we were doing remote access, they'd be connecting through the Connect Secure SSL VPN gateway instead. The Policy Secure solution is compatible with any vendor's 802.1x capable switches and wireless access points, and we have specific customizations for integration with Aruba and Cisco for guest user access. Now, in order to determine what access to provision on these switches and wireless access points, we have to identify what the device is, who the user is that's operating it, and what role they belong to. We do that by tying into a variety of backend data stores and to leverage some of the functionality that can be added by using device profiling, as well as existing LDAP, Active Directory, RSA, etc. Once we know who you are, another question we might want to ask is, what is the status of the device itself? For mobile devices, we have integration with the leading MDM vendors, MobileIron and AirWatch, to dig a little deeper into the endpoint and determine whether that phone is a personal or a corporate managed phone. If it's corporate managed, is it compliant with the security policies, etc. Once we have all that information, we can make an initial access control decision, but we might want to modify that decision based on the behavior of the device in the network. And in order to do that, we leverage an open standard for security automation, which allows us to use third-party components as sensors for behavior, location, and other data that can be used to affect an access control decision. We call this coordinated threat control. So these are all of the various tools and infrastructure components that can be coordinated by Policy Secure to provide dynamic, intelligent admission control. The fundamental technology that underlies admission control is 802.1x. 802.1x is an authentication mechanism that allows a switch or a wireless access point to query an end device and get back information about the device. This open standard has been around for decades, literally, and so it's very broadly supported across enterprise switches and wireless. 802.1x enables us to query for user identity and for the MAC address of the endpoint itself on almost any device. Most operating systems these days have an 802.1x supplicant built in, so you could use the native 802.1x supplicant in Windows, OS X, Android, iOS, Linux, Solaris, etc., and you could get back some basic information about the endpoint. And the Pulse client enables us to get back more detailed information about the endpoint. And then once we have that information, we can use the radius capability to push down decisions to the switch or the AP. And those decisions could be to accept or reject the authentication, to assign the device to a specific VLAN. If the enforcement point is a layer 3 switch or a wireless access point, you often have the capability to apply an ACL as well. And you could even get into more sophisticated radius attributes such as quality of service, bandwidth management, etc. So 802.1x and radius allow us to gather information from the endpoint, make a decision about the access class of that endpoint, and then push policy down to the switches and APs to determine what VLANs, what ACLs, and possibly what advanced features like QoS need to apply to it. So I mentioned that the Pulse client makes the 802.1x information gathering process more detailed. Using the Pulse client, we are able to do posture checks on the endpoint using our host checker. And this allows us to look for things like, is hard drive encryption present and enabled? Are they running an antivirus package? And if so, are the engine and signatures up to date? Is the firewall turned on? Do they have appropriate anti-spyware, anti-malware? On OS X, we can also check for things like existing running processes, files, and whether particular ports are open or closed. On Windows, we can go even further and look for things like patch checks, We can look to see whether the machine itself is a member of the domain. We can check registry settings, and we can even do custom policy definitions. So if you don't find what you're looking for in the predefined checks, you can write your own. We do apply the host checker to Linux and Solaris as well as to Windows and OS X. For Linux and Solaris, the checking is limited to running processes, existing files, and TCP or UDP ports. So once we know who the device is, we can make an access control decision. But how do we get to that point? If I come in with my personal phone, how do I connect it to a network that's doing admission control? Obviously, the native supplicant is helpful for this process, but it's unrealistic to expect every user of a mobile phone to be able to configure their own 802.1x settings on their phone. And you certainly don't want them to have to go through a help desk or an operations team to do so. Policy Secure offers self-service device onboarding that applies both to our VPN and also to admission control configuration for things like Wi-Fi settings, 802.1x configuration, and device certificates. It's a self-service process, which means it can be completely hands-off. But if you are running an MDM in your organization, you can also tie it back to your MDM to do advanced checking on the endpoints that are corporate managed. So what does this look like for an end user? Let's say I come into the network and I have a new phone and I want to connect it to the corporate network. The first step would be to connect to an open SSID that leads me to a portal. And that portal could ask me, is this a personal device or a corporate device? So I could choose whether it's BYOD or a managed asset. On that portal page then, I could enter my credentials, and that would allow me to associate that device with my identity within the organization. That will lead me to an onboarding link. The onboarding process then reaches out to the device and configures it with SSID, other Wi-Fi configuration if necessary, 802.1x configuration, and any certificates that are needed. So the device then disconnects from the open SSID and uses 802.1x to authenticate itself to the secure SSID with a device certificate. All of this process takes place in the background. Once the user clicks the onboarding link, all they have to do is wait for it to step through the process. So this is my experience on day one, and the nice thing is I only have to do that once. When I come in the next time, I will automatically connect to the secure network using the credentials and properties that were already configured. So it's a really simple process. In support of mobility, there are a variety of different ways we can handle endpoints such as laptops, tablets, and smartphones. We already talked a little bit about the native 802.1x client. That allows us to authenticate the user either by user identity, username and password, or by certificate. And it also allows us to collect the MAC address of the endpoint. We can tie that back to MDM if desired to get more information about the device. And on Windows and Mac OS X, we also have the option of integration with the Pulse client. So the Pulse client brings us the posture checking capabilities that we discussed. So